To start our units on kinematics, we're going to start with a basic motion warm-up to just review the couple formulas that you learned in grade 10 science. So the first formula that you would have learned is distance equals time times velocity. Now there's a couple things about this formula that are important to realize. The first one being the velocity. There's a little bar over top of this V, and that bar means it's the average velocity. When dealing with something that's not accelerating, the average doesn't really matter because the velocity is the same the entire time. But we're going to be dealing with stuff that's accelerating, which means the average velocity is going to be changing. We're going to get something like our initial velocity plus our final velocity divided by 2, right? We're finding the average of an initial speed and a final speed divided by 2, and now we can use it in the formula, okay? And of course, where D is the distance in meters and T is the time in seconds, okay? That's formula number 1. Formula number 2 involves a constant acceleration. The change in velocity is equal to acceleration times time. This triangle thing is called a delta. Okay, it's a Greek letter delta, and what that means in the physics world is it's change. So if we're looking at the change in velocity, delta V, that is your final velocity minus your initial velocity, okay? Which means this formula, how I like to write it and how I like to look at it, is our final velocity is going to be our initial velocity plus the acceleration times time, where I just plugged in my V final minus V initial and then moved the V initial over to the other side, okay? Either way, it doesn't really matter how you look at this question, okay? All these units have to be meters and seconds, so we've got speed in meters per second, acceleration in meters per second squared, and time in seconds. So let's use this to solve some examples. This first example, a car traveling 550 kilometers in 3 hours, what's the average speed of the car? Again, average speed should clue you in that you should be using your D equals TV formula because that's the average speed. We've got a distance in kilometers and a time in hours, which means we can leave it like that because we are going to get a speed in kilometers per hour, right? If we had kilometers and seconds, we'll get a unit of kilometers per second, which again doesn't really make sense unless you're a rocket ship. So we're okay with leaving these units in kilometers and hours because they work together. And after that, it's just plug and chug in our formula, divide by time, 550 divided by 3. So you should get 183 kilometers per hour. For the second question, we are looking at a car accelerating from rest for 10 seconds, okay? Right away, those two things tell us if it's from rest, that means our initial velocity is 0, and our 10 seconds, our time is going to be 10 seconds. After 10 seconds, the car is traveling at 24 meters per second. We want to figure out how far the car traveled. Now, if we think about our acceleration formula, because we see the word accelerate, there's no distance in there. And we aren't given an acceleration. So really, we can't use that formula. The only formula we can use is our distance one. And since we know it starts from rest and ends at 24 meters per second, that means we can find our average velocity, which is 12 meters per second, right? It's not going at 24 meters per second the entire time. It starts at 0, ends fast, which means our average is right in the middle. And we can use that average in our formula, D equals TV, and figure out that it went 120 meters, okay? Now, if we wanted to do an acceleration problem, we've got a runner accelerating at 0.7 meters per second squared. So there is our acceleration. And it wants to know how fast they're running after 4 seconds. So they're accelerating for 4 seconds, which means they're going to get a change in velocity. Their change in velocity is going to be 2.8 meters per second based on their acceleration for 4 seconds. If they start at 6 meters per second initially, well, that just means, all right, if we're changing our velocity by 2.8 meters per second, start at 6, add 2.8, we get 8.8 meters per second. You could also just write this as V final equals V initial plus AT, which will be your 6 plus 0.7 times 4. You're going to get exactly the same thing, 8.8, right? That's going to be exactly the same thing as we did before, just a different way of writing it, okay? This last question, a car braking, this one's yours. We'll go over this in class. You can try this one. These are just basic kinematic formulas, good practice to get you warmed up for this unit.